Ever wondered what happens in that split second after you click a link, type in a website, or send a message? It feels like magic, right? But it's not magic. It's a mind-blowing system of digital post offices, secret codes, and lightning-fast data delivery. And in the next 10 minutes, I'm going to reveal exactly how the internet works, in a way you'll never forget. So let's start with your device, your phone, laptop, or tablet. In the world of the internet, this is called the client. Think of yourself at home, wanting to send or receive a letter. Now, where does all the information on the internet live? On massive, powerful computers called servers. These are like giant digital warehouses or libraries, storing every website, video, and cat photo you can imagine. When you want to watch a video, your device, the client, needs to ask the server for it. But how does your device talk to the server? They don't speak the same language. That's where your web browser comes in. Chrome, Safari, Firefox, you name it. Your browser is a brilliant translator. You type in a website, and the browser translates your request into a language the server can understand. This language is called HTTP, or even better, HTTPS. Think of these as the official postal service rules. In HTTPS is super important. It stands for secure. It's like sending your letter in a locked, tamper-proof box, so no one can peek at what's inside. We'll get more into that security aspect in a bit. Now, here's where it gets really cool. You don't send your request as one giant message. That would be like trying to mail an entire encyclopedia in one go. Instead, the internet breaks your request down into tiny, manageable pieces called packets. Each packet is like a small envelope. It contains a little piece of the data you want, plus 2 crucial addresses. The address of the server it's going to, and your own address, so the information can find its way back to you. This is your IP address, your unique digital home address on the internet. Ever seen a set of numbers like 192.168? 1.1? That's an IP address. But wait, we usually type in names like YouTube.com, not a long string of numbers. So how does your browser know the server's IP address? This is where the internet's phonebook comes in. The DNS, or domain name system. When you type YouTube.com, your device first asks the DNS, "Hey, what's the IP address for YouTube?" The DNS server looks it up and replies with the correct numerical address. Now your packets are properly addressed and ready to be sent. So, you have all these little packets, these digital envelopes, ready to go. How do they travel across the globe in milliseconds? They enter the grand postal system of the internet. This journey is managed by routers. Routers are like the super efficient sorting facilities and post offices of the digital world. When a packet arrives at a router, the router looks at its destination IP address and decides the fastest, most efficient path to send it next. Might bounce through a dozen routers, underwater cables, satellites, fiber optics, all to find the quickest route to the server. Comment your internet speed below. I'm curious to see what you're all working with. Once all the packets arrive at the server reassembles them in the correct order, just like putting together a puzzle. It then processes your request. Let's say you wanted to watch a video. Server then does the exact same thing in reverse. It breaks the video file into thousands of tiny packets, addresses each one to your IP address, and sends them on their way back through the internet's network of routers. Your device receives these packets, your browser reassembles them, and voila! The video starts playing on your screen. And this entire round trip, from your click to the video playing, happens in the blink of an eye. It's an incredible symphony of technology. What part of this process has surprised you the most so far? Let me know in the comments. Now, let's talk about that S in HTTPS again. Why is it so important? When you send packets using regular HTTP, it's like sending a postcard. anyone who intercepts it can read it. But with HTTPS, your browser and the server agree on a secret code first. JET. Every packet is then encrypted, scrambled into an unreadable mess for anyone without the secret key. This is crucial for protecting your passwords, credit card numbers, and private messages. Here's a pro tip. Always check for that little padlock icon and HTTPs in your browser's address bar before entering any sensitive information online. It's your first line of defense. Tag someone in the comments who needs to know this tip. Serve. We have clients, servers, browsers, packets, IP addresses, DNS, and routers. That's the core of the internet. But what about new technologies, like AI? How does artificial intelligence fit into all this? Well, AI models, especially machine learning models, are incredibly data hungry. They are trained on massive datasets, often stored on servers all over the world. The internet infrastructure we just discussed is the very highway that allows developers to access this data and for AI services to function. When you use an AI chatbot, your question is sent as packets to a powerful server. The AI model processes it, and the answer is sent back to you in packets. AI is using the same postal system, just sending and receiving incredibly complex information to perform its tasks. Let's recap our postal system analogy one last time. You, the client, write a letter your request. Your browser translates it and puts it into thousands of tiny address envelopes packets. The DNS acts as the phone book to find the right address, IP address. The routers are the post offices, sorting and forwarding your envelopes along the fastest path. The server receives and reassembles your letter, then sends its reply back the same way. All of this is protected by the locked box of HTTPS. It's a simple analogy, but it perfectly explains a deeply complex system. A quick pro tip. You can find your own public IP address just by searching "What is my IP address?" on Google. Don't worry, it changes often and is generally safe, but it's good to understand what it is. Understanding these fundamentals isn't just for tech geeks. It empowers you to be a smarter, safer digital citizen. You now know why secure connections matter and what's happening behind the scenes of your screen. The internet is arguably humanity's greatest invention, connecting billions of us in a web of shared knowledge and communication. Hopefully, it feels a little less like magic now, and a lot more like ingenious engineering. If you found this explanation helpful and want to see more breakdowns of complex tech, do me a huge favor and hit that like button. It really helps the channel grow. And make sure you subscribe and turn on notifications so you don't miss our next video. Thank you so much for watching, and I'll see you in the next one.